but in a shooter game you can shoot the walls too, which cannot be represented by a sphere. It should be a plane. The wall is a plane, actually a quad, so there is four vertex, and that's a quad. Okay, plane can be represented by a normal vector and a point. The nx, ny, and nz are the normal vector x, y, and z coordinate. The x0, y0, and z0 is a point on the surface, not matter which point, so you will get the same, not matter which point you choose, but you will choose a point, and yeah, that's it. Okay, and that's about it, how we can calculate a plane point. Obviously here the x, y, and z will be a point on the plane, any point you want, depend on what you use. Alright, and in the ray it is basically the same as earlier. Again, we can do the same trick as previously, so I just copy this x to here in the place of x, the y to the place of y, and the z to place of a z. Okay, here is it. As you can see, I just copied the x, y, and z to the place of x, y, and z. This is how this is comes. So it is pretty simple until this point. Now I do the multiplication, so I multiply the ns by nx, the t times xd with the with nx, and yeah, that is how we do it. Okay, and after we do that, we get this long line. Okay, but we want to know the t, so actually we first, so I just pack everything which is not t to the other side. First of all, I start with the negative expressions like this, and there are 3 more of these. Then I subtract the other expression like this nx times xs. So everything I subtract and add which doesn't contain a t. Which contain a t, I will divide with it. So everything which is not t. So in this case, for example, I divide with nd times nx. Okay, and after I do that with the whole thing, I get this line. So we only have to put everything in here. So x0 is the x coordinate of a point, and so on. So I just put it here, and then that's about it. We get the t actually quite easily, easier than the previous one. Now we actually need to know that is it the quad or it is just the plane, because the plane is an endless thing. Okay, if this is 0, so xd times nx blah blah blah, so this is, if this is 0, then we cannot do the division because we don't like to divide by 0. So it will basically mean that the ray is parallel to the plane. There is no collision, never and ever. Okay, and that's what I said. Okay, now we get the t. We have to put it back to these 3 equations. So I get the t, I know the xs and the xd, I put the t in here, and I get the x, y, and z coordinate. Now I know the coordinate, so I need some way to find out is it the quad or is it the endless plane. Okay, there is a lot of writing in here, which basically I do in here, that I get the collision point, and I know the quad, it has 4 points. Now I divide this quad by two triangle by draw the diagonal in here. As you can see, it is 2 triangle. Any quad can be separated into 2 triangle. Why do I use triangle? Because it's simpler. Okay, so I have a collision point right here. So in here I could draw it if I want. So here is the collision point. Okay, and now there is the collision point, and with this collision point and the other point of the triangle I can make 3 more triangles. So I have one quad, I divide this one quad to 2 triangles, and I separate this one triangle into 3 other triangles. Now the trick in here is I calculate the area of this triangle, and this triangle, and the main triangle too, and I compare them. If the area of these 3 little triangles is the same as the area of this big triangle, then the point is inside. If the point would be outside, so for example, let me draw a point outside, for example in here, then the 3 triangle would be one this, okay, and this. As you can see, it is obviously bigger, so the area of this 3 triangle is bigger. Alright then. Now yeah, let's see. So here is what I said. Okay, we calculate the area of the triangle by something called the Heron formula. This is actually very simple. I just get the circumference of the circle, I divide it by 2, so here I represent with S, here is it, okay, and I use this formula to calculate the area. So I get the square root, and I use S times S minus A times S minus B times S minus C. This is the Heron formula, and this will give the area of the triangle. Okay, let's see it's in code. But now that we saw the theory behind the ray plane collision detection, let's start decoding. So it will return a bool as well, and it will be ray plane, the name, and we need a normal vector, so float nx, float y, ny, and float nz. Okay, and we need the start point of the ray, so float, this will be the xs, float x sy, and float sz. Ys and zs. Okay, and then we need the direction vector, so float of the ray, obviously, float xd, float yd, and float zd. Okay, and I believe only the point of the quad remains. So instead of write 12 more float variables, I include the object loader here, so include obj loader, and now that I included the object loader header file, I can use the coordinate structure, which is basically just 3 float numbers. So instead of 12 more variables, we need just 4 more variables. So coordinate, this is the name of the structure, and I call it P1, and coordinate P2, coordinate P3, and coordinate P4. That's right, and we are ready with the prototype. So now I just copy this to save time under this other ray tracing algorithm and paste it. Now first of all, as you can see in here, we need to calculate this. So xd times nx, yd times ny, and zd times nz, which is basically the dot product of the direction vector and the normal vector. And if it is 0, then it means that the ray is parallel to the plane. There will be never a collision. So that's why I make a variable, because we use it 2 times. First to examine that is it 0 or not, and second times in the division if we do. So float, I don't know, call it what should it call it, a, never mind, and I just type it nxd times nx, or yeah, plus yd times ny plus zd times nz. That's right, I think I wrote it good. So now if it is 0, so if oh, what am I doing? So if a is 0, then we just return with false, because if it is parallel, then it will never touch the plane. So yeah, that's the case. Now we need to actually calculate the t, so I just write this long line to here. Okay, I maybe cut this because it's long that it is long that I just type in and boring. Okay, I just typed in this line. Actually it is almost the same as the line in here. There is two little difference. One is the x null, y null and z null is not exist. Instead I will use the p1 as a point. I could use p1, p2, p3 and p4. I will get the same result. So I use the p1.x, p1.y and p1.z instead of x null, y null and z null. Okay, and the other difference is that this long expression, which is the normal vector times the direction vector, is I represent with a, because I've already calculated it. I don't want to calculate it again. And now if the t is less than 0, it means that the ray is collide with this plane in the negative direction. So for example, a weapon don't shoot the bullet in front and in back, just in front. So that's why we return with false again if the t is 0, less than 0. Like here is an example. As you can see, this is the plane. The vector goes in this way, so the ray goes in this way, but because it is negative, it will actually do the collision. So the collision happens actually in here, so behind this behind the ray, and we don't want that. So that's why we return with false, because there is no collision. Now we calculate the x, y and z coordinate of the collision. So where does that happen? So float x, and the x equal to the start point, so xs plus t times xd. It is the ray equation, if you remember. Okay, I do the same with the y and z too. So y and z, so I call it y, z, y, y, z. Okay, I calculated a new point. This is where the collision happens. So this x, y and z coordinate. This is what I will use to create a free new triangle. Okay then, before I move on, I create a new function which will calculate the area of the triangle. So float, it will return with the area, and I call it triangle area. Okay, and it will wait 3 points, so coordinate p1, coordinate p2 and coordinate p3. Okay, and it will return the area as I said. Okay, so now I just implement this function somewhere. Not really matter, here I implement it. Okay, so we use the Heron formula to calculate, but first we need to calculate the length between the 2 points. So we use the Pythagoras theorem for that again. So float a, and the length of a will be square root sqrt, and so first I need to create vector of this, and I create vector of this by subtract the start point from the end point. So in this case, for example, p2.x minus p1.x, and I do it again, so I multiply it by p2.x minus p1.x, because we want the square of this, because that's how the Pythagoras theorem said, a squared plus b squared plus c squared, and this is all under the square root. Okay, and I add the same with the y coordinates, so I just copy it to save time. Okay, so this will be y, and again y, plus, and again with the z coordinates, so z, that's right. So I just calculated the length of A with the Pythagoras theorem, and I created a vector by subtract the endpoint from the start point, or the start point from the endpoint. Never mind. So you can exactly see what is going on if you draw a right triangle in the paper, and then you can see how this comes. Okay, I do the same with the B, C, and BC. So B, and C, called B, not V, B, and this is called C. Okay, the only difference will be that this is the other two sides. So this is P3 minus P2, P3 minus P2, P3 minus P2, and yeah, that's what we do. So P3 minus P2. Okay, so this is the other side, which is goes from P2 to P3 point, and we have one more side. This is the point which goes from P3 to P1. Okay, that's right. So I just rewrite this. Actually, the order is not matter, that P3 to P1 or P1 to P3, because we get the square of them, and that if it was negative then it will be positive, and yeah, the length will be the same. Anyway, now we need to calculate the half of the circumference. So float A, and not A, call it D. Okay, and this will be S. Okay, so A plus B plus C, and this is divided by 2. Okay, and now we will just return with the sqrt S times S minus A times S minus B times S minus C. Okay, that is how the theorem formula look like. So this will get the area of a triangle. Now get back here and let's calculate it. Okay, as I said, the x, y, and z point will be inside the triangle if the big triangle, so where is it? Oh, here is it. So if this big triangle area is the same as the three small triangles area. Okay, so I just go back to the to here, the ray plane, and I use an if. And actually, before I do that, I create a new coordinate from this x, y, and z coordinate. So a coordinate, and I call it collision point CP, and this will be x, y, and z, because I can only give coordinate parameter to this where is it, triangle area function. That's why I have to create that. And now actually okay, and now it's time to calculate the area of the triangles. I did a little drawing here which may help to visualize what triangle area should we add and so on. So yeah, this is our quad, and I divided it to two triangles, and this two triangle is divided by divided to three more triangles. So for example, if P1, P3 and P4 area is equal to P1, P3 CP, P1, P3 CP and P4, P3 CP area, then the point is inside that yeah, the point is inside. Okay, by the way, one more thing before we go on is that I don't use that the main area is equal to the area of these three. Instead, I calculate the main triangle's area and I subtract all of the other areas. I put it in absolute value and I see what the value is. That's because, for example, if there is a number 1.0001, that's not equal to 1.000. So there is a very small difference, but it makes it not equal. This wants to be a not equal. Okay, and yeah, that's a problem because the precision is sometimes cause some very small changes. But if I do that, this 1.01 minus 1.000, and I check what will remain after this subtraction. So if it is less than 0.001, then it will be equal. That is the threshold, the precision, what we want. So for example, if I write 0.1 in here, that would mean that 1.1 is yes, so 1.1 is equal to 1. So that is the precision. We obviously need some higher precision, so like that approximately, and I put in absolute value, so ABS. So it does not matter that the first one is the greater or the second one, it will be a positive number, because the absolute value is, in case of, for example, -5, it becomes 5. In case of 5, it remains 5. So not matter that it will be the first is the bigger number or the second, the absolute value will be a positive number. So that's why we can use this less than sign. Okay, then, so let's calculate it. Where is it? Oh, so first of all I put an if and then an absolute value, and then I get the main triangle's area. So in this case, for example, P1, P3, P4. So P1, P3, P4. Okay, and then I subtract the this one to be triangle area. So is the triangle area P1, P3, P4, which is the main triangle, as you can see, minus triangle area P1, P4, CP. P1, P4, CP minus, and then another one P1, P4, P1, P3, CP okay, and minus triangle area, this will be the last one, P3, P4, CP, P3, P4, CP, and I close the absolute value parenthesis is less than I don't know 0.01, so just the precision, because usually there is just small such small differences between the two, but it will not give an equal. That's why I use this method instead of using an equal sign here and additions here. So minus. Okay, then now we need an OR because we have two triangles, and not matter that the collision point is in this triangle or in this triangle. So yeah, it's not matter because they are the same quad. So I use an OR, and again I just type it. Now I don't show you where does that come from, just type it quickly. Maybe I cut it even, I don't know. So if again let's start with absolute value, triangle area, and again I get the main triangle, so P1, P2, P3. Oh yeah, I wrote it good. Okay, and then triangle area P1, P2, CP minus triangle area P2, P3, CP minus triangle area, and the last one is P1, P3, CP. Okay then, and if it is less than 0, 0, 0, 1, okay, so if it is true, so one of them is true, so the collision point is inside one of the triangle, then we know that there is a collision, so we return with true, else we just return with false. That's right, and our function is ready to use. So now I just go to the fur.cpp and I draw a plane right here, for example under this line, not really matter where. So I draw the plane, so GL begin, GL quads as always, and then GL end. Okay, and here I just draw the plane, so I will be back, I just find a plane. Okay, here I've just found the plane, so I hope the keyframes are okay. So this is just, if I would run the program now, I think we can run the program now. Oh, by the way, I think I forget to show you that there was an error right here. This T parenthesis wasn't closed. I think that was the only error I got earlier, but never mind. So now we may get new errors. Isn't it great? So I just compile the program. Yeah, compiling. Okay, and run the program, and here is it. As you can see, this is just a big plane. The length of all sides is 10. You have already drawn planes. Okay, so here is the 4 vertex. As you can see, you can copy it if you want, or you can make other planes. Okay, so now I just call this ray plane function, which I did a little bit earlier, but I will call it again. So if ray plane, and now we can give first of all the normal vector, if I remember well. So ray plane, there is the normal vector of the plane. In this case it is 0, 0.0, 0, 0.0 and 1.0, so it is parallel to the z-axis and it's looking toward us. Okay, and then the next parameters are the start point of the ray. This will be the ray start.x, ray start.y, and the ray start.z. Okay then, and then we need the the direction vector of the ray. This will be a little tricky because now the ray will go in a different direction than earlier. So instead of 1.0 it will go minus 1.0. Yeah, not really matter, basically just so there will be an intersection. Okay, and then where is the next? Oh, the coordinates of the plane. Oh, I forget to show you that I've created 3 coordinates with these are the same coordinates as the plane coordinates, as you can see. So these are the same numbers. I just created the 4 structure with it, 4 instance of a structure if I want to be more precise. And now I just give these parameters to the array plane. Okay, so I give p1, p2, p3, p4, and that's it. Okay, so if it is true, then we change the color, ref, we change the color to red again. Okay then, and now I think we can run the program if I don't forget anything else. Yeah, I moved the array start z coordinate from -5 to 0. That's all. I think that's all that I did, so nothing really interesting. Now we can try to compile the program, which I succeeded in that, and now I can move the array with the keys as earlier. Okay, I can start the program, but as you can see there is a little bit of problem. Although I changed the direction of the array, I don't change the direction of the line which represents the array. I can fix that very easily by here where I draw the line, so the array, I set it -1, so the new normal vector, not the old one. So now if I run the program, you can see the direction of the line is the opposite as it was. Now I can move up, down, right, maybe that's better view for right, left. So as you can see, it's approximately work. Maybe we should keep the threshold a little bit smaller, but you see it's work approximately in every direction. Okay then, by the way, probably it was a quite boring chapter because there was nothing too interesting in it. There was just a few line and sphere and plane, but it is a very important chapter because tutorial, actually not chapter. Okay, so it's a very important tutorial because it will be the base of the sphere plane collision detection too. And it can be used for ray tracing, obviously for lighting ray tracing I mean. Then it can be used for bullets and quickly moving objects too, and so on. If you don't understand the math, try to find yourself, so try to find out yourself in a paper. That's definitely help. Sometimes if someone else do something in math I don't understand, but when I have to do the same thing I understand. So that's why I recommend to use a paper, a pen, and try to find yourself these simple formulas. Okay, and if you don't understand completely, not help the drawing paper, don't worry, the math will work even if you don't understand. Okay, that was this tutorial. Thank you for watching and have a great day.